Hello friends. Today let us study about the metallic nanoparticles of the unit 3 of the nanotechnology elective subject of 8th semester. Metallic nanoparticles. So we know about the nanoparticles. Nanoparticles are the nanoparticles size 1 nanometer to 100 nanometer. Okay, so that there are different nanomaterial particles, different types. Okay, so that those are made of metals, semiconductors, and insulators. Now, the nanoparticles, the nanoparticles prepared by metals are metallic nanoparticles. We give the symbol MnP for metallic nanoparticles. These the metallic nanoparticles are again in zero dimension or quantum dots. Okay, these are also called nanoparticles. One dimension nano wires or nanofibers, and is also of two dimension nano films. So metal nanoparticles are in form of zero dimensional nanoparticles, which confined to nano scale in all the directions. Two dimensions are confined in nanoscale. One dimension is extended, so that this is nanowire and nano films. So that and quantum dots. So similarly in semiconductors and insulators also we get quantum dots, nanowires and nanofilms. But let us restrict it to the metallic nanoparticles. There are the several metals, so that they produce the nanomaterial particles for different applications. For examples, gold nanoparticle, silver nanoparticles, iron nanoparticles, cadmium nanoparticles, and another one platinum nanoparticles. So there are different. So based on their properties, they have various applications. For example, gold, silver, platinum, these are the very good, the metallic conductors, they are precious metals, and for that purpose, in case of the metallic films, in case of conducting films, so we use gold and silver, gold, silver and platinum nanoparticles. Similarly, in case of connecting the wires, or we call this as ohmic contact, in case of the semiconductor circuits, we use gold nanoparticles, silver nanoparticles and platinum nanoparticles. Similarly, iron and cadmium nanoparticles they are magnetic in nature. They are used for the used as magnetic nanoparticles, and they are having their own applications also. Now, so that the how it comes here. So in earlier in as we know, this is the study of nano materials. Not it is new. In medieval era also we have the nanoparticles. They were preparing nanoparticles, but they don't know whether those are nanoparticles or not. Because they don't have the microscope to study the nanoparticles. So that we already studied. So in medieval era, to decorate windows, the windows of churches, Greek were using the nanoparticles. Okay, so now another one later at in 1857, the Michael Faraday prepared what? Gold colloid. Gold colloid. So colloid means the nano powder suspended in the solvent. Solvent may be in water, or in case of in alcohol, ethyl alcohol. The gold, the molecules are suspended. Actually, the gold used in that are gold nanoparticles. Again, in so 1908, what happens? There is another scientist, so who explained this? They give the explanation of color of nanoparticle. Okay. What happens? Color change will take place from bulk is yellowish one, it changes to deep red when the bulk gold is macro gold is converted into nano powder. So that he gave the explanation. So this is explanation is given by the scientist called me. Scientist called me gave the explanation related to the gold nanoparticles. So in 1925, Richard Z. Okay, Zygmunt is name. He studied the colloidal chemistry of the gold soles. Soles means again gold particle, nanoparticles suspended inside the liquid. That solution again it is called sole. Okay, so that he invented the ultra microscope. Invention. Ultra microscope. For that he got the Nobel Prize. Okay, so that there are what are the properties of What are the properties of the gold nanoparticles? So as usual, this is normal property of any of the nanomaterial. So the large surface to volume ratio. Large surface to volume ratio. Similarly, metallic nanoparticles also having large surface to volume ratio. So that the large surface to volume ratio enables the exposure of surface atoms okay, surface atoms, and so this in turn reduces the melting point. Reduction in melting point. So that drastic reduction in the melting point takes place due to high surface to volume ratio. So next, second one. So it is having the usually compared to bulk. So large surface energy surface energy is very large. Okay, it can squeeze any of the material, so that due to the large surface energy, then what happens, it is the size of the nanoparticle increases very much fast by accumulating more and more atoms. Okay, so that surface energy is very large. Okay, and this surface energy, it is different makes metallic nanoparticles different from atoms and bulk metal. Well, atoms or molecules. You can write molecules. Atoms are molecules. So this surface energy, the concept of surface energy is very much different from the bulk. Bulk having very least surface energy, and atoms are there is no concept of surface energy in case of atoms and molecules. So the surface energy differs. So third one, plasma excitation. plasma excitation. So it having, so this plasma excitation, we know that excitation means what? So that by the absorption of some energy, what happens? So that energy is converted into some other form. So that electron at, for example, when for the, in case of two energy levels, the electron in ground state excites to upper energy state. This is an excited state we call, by the application of energy. Okay, these are in case of electron. Similarly, the plasma is the group of charged particles. Okay. Here, group of charged particles. What are charged particles? Charged particles are two types. One is electrons and another one ions. So that ions are positively charged particles and the electrons are negatively charged particles. We know that the metals contains the free electrons and are also called valence electrons. So for that purpose, so these valence electrons are not, this is lightly bound to the surface. So for example, here electrons which are present on the surface of the metal, so that when some amount of electromagnetic energy is incident on this, these electrons get excited outside. But for these electrons, so here also, this is again electron get excited. Then when these electrons come back to the original on the surface, these electrons always will not going to be free. So that for that purpose, this electron again come back to the surface. In this case, they emit the electromagnetic radiation again. So hence, because of this electromagnetic radiation, the metal is shiny. So in case of semiconductor and insulators, there are no free electrons. We don't get free electrons. Hence, so that like metals, semiconductor and insulators are not going to shine. So light may reflect, but here the shine is due to the emission of electromagnetic radiation. This type of the emission of electromagnetic radiation due to these excited electrons, those are called plasmons. So excited electrons are plasmons. These plasmons, due to these plasmons, so that the electromagnetic energy is emitted, that is called the plasma resonance. We come later, let's come to that. So the different metals having different colors. For example, gold shines with yellow, and silver is whitish, white light it emits. Okay. Similarly, platinum also it emits the white light. So there are the very good conductors gives very good surface plasma resonance. Okay, so that this is the plasma excitation. This is a property of the metallic nanoparticles. Next, you already know about this quantum confinement. Quantum confinement. So that quantum confinement. So confinement of the electron to the small space, that is called the quantum confinement. Means the size of the nanoparticle is restricted. Restricted means the size become nano, some particle is confined, so that the electrons also, when the quantum confinement is there, so in this quantum confinement is number of the atoms go on reduce. In the direction of quantum confinement, the number of energy levels also reduce, so that the here for usually, for example, in case of the bulk material, in case of metals, if you see the energy levels in a particular band, energy band, so that these energy levels are very much so closely associated. You know that conduction band, valence band, all this in this, so that it is the completely continuous, it appears. Difference in energy here, what happens, you know that I draw the line, but what happens after drawing number of lines, those represent the different energy levels, so completely it appears like this patch. It's what? So difference in energy is almost the continuous, it shows. So when it happens, it is bulk, large number of atoms are put together. In case of nano, what happens? Fewer number of atoms are there. In such cases, in a given band, here consider it small interval of energy level. Then in this case, so that these energy, compact energy level, this density is very high, this becomes lower density here. So that due to the confinement, when the particle, when the material get confined into small size, discreteness of energy level takes place. That is called quantization of energy level. That is the property of, that is also the property of the metallic nanoparticles. Then this here they show short range ordering. Next, short range ordering. Short range ordering. They show short range ordering. Okay. So here ordering is very much large in case of bulk material, so that the number of atoms are so neatly distributed in the three-dimensional. So that in case of this, the bulk crystals, metallic crystals, there is long range ordering. But here in case of nanoparticle, it is short range the ordering. So for that purpose, in case of the nanomaterials, usually like in case of nanofilms like that, nanofibers, we find the kings, means number of bands, strains, like that. So this type of here, so that is called usually low coordination sites. So that we call the low short range ordering. In that the atomic arrangements, all this in that on the surface we observe. So that is called low coordination sites. We call that is in that contains corners, edges, like that. So that observed in case of the metallic nanoparticles. So next, let us dangling bonds. Up. Dangling bonds. These are characteristics. They have character dangling bonds. What are these dangling bonds? In case of any nanomaterials, all this we know that they are having large. This happens due to the unbalanced electrostatic force. So that this unbalanced force is very much less on the surface of bulk material. But in case of nano, we having the large surface to volume ratio, so that in case of nanoparticles, there are very much large number of atoms on the surface compared to inside. Here, compared to inner atoms, so that there are large number of atoms outside. So inside this the force is balanced. But when you go outside, then what happens? The balance is, there is no balance, so that imbalance, so that there is no any force at this is, the pull is in this direction somewhere inside, pull is inside, but what happens outside? No. So that this outside, the bonds are free, and also they also having the free electrons, because of electrons did not bind to anywhere. This type of bonds are called, these are called dangling bonds. These are called dangling bonds. So these dangling bonds appears. So due to this, they are ready to react with any, club with any outside atoms. So in case of metallic nanoparticles or any nanomaterials, so that we can see, so increased chemical reactivity. Increased chemical reactivity. Okay, hence they acts as catalyst. Increased chemical reactivity. Hence they act as the catalyst. Okay, so that hence this type of the nanomaterials, so that the metallic nanomaterial MNP have number of applications. In, so that one, nanosensors, biosensors. Okay, in case of the nanoelectronics, and in case of nanomagnetism, they are having the number of applications in biochemistry, so they study the particularly the study of DNA and the cells, like that, biological activity. In this case, the surface plasma resonance, the characteristic is much useful. So this is also useful in case of some medical and drug delivery, etc. Okay. Now, what are the drawbacks? What are the drawbacks of the metallic nanoparticles? Limitations or drawbacks. And limitations. Okay. So that they having particle instability. So stability of the particle is the questioned here. So in this case, what happens? As I know, the many drawbacks are due to the presence of dangling bonds. Okay, unsatisfied bond, and dangling bonds are unsatisfied. Usually, what happens here? The stability, because of that purpose, the stability is so. This is they having thermal instability. So we know that the metallic nanoparticles having a very much a small the melting point. Okay, so that is the one drawback of the nanoparticles, and they are also thermodynamically unstable. Okay, so that here the deterioration of quality. Usually what happens here, the size of the nanoparticles are not stable. Okay, so that there is a possibility of reacting with the any material, immediate reactions. So for that purpose, quality. Here what happens again? So poor corrosion resistance. Immediately it corrodes. Why? So that because of again dangling bonds that get oxide. So that converted to oxide of particular metal. So that what is corrosion? Corrosion is nothing but oxide of that metal. Similarly, compared to the metal, the corrosion resistance is very less for this. Suddenly they get corroded. So that difficult to the structure instability. Yes, so that the structure they cannot retain the structure. so properly. This is the one drawback so of the nanoparticle and the particle instability. The second one is the impurity. So that impurity is another one. So these are highly reactive. So what happens normally? It converts into nitrides, oxides, etc. due to the salts, due to traces of salt present in solvent. So that either in solvent or when these nanomaterials are kept outside in environment also, so that when some this air come into contact or these some traces of salt present in solvent, they immediately react with this one, so that the conversion taking place, they don't remain pure. Nanoparticles are not remain pure. Okay, so for that purpose we need to encapsulate. Encapsulation is very important. Encapsulation of the nanoparticle, it is another. So that in this case what happens, a nanoparticles, when it is immediately formed, there is due to some way this is encapsulated, so it is covered. So that is some transparent polymer or some transparent conducting oxides, so that those are encapsulated over the nanoparticles. So that whenever the applications are there, so that if need, this encapsulation is removed, or with encapsulation, so that the nanoparticles are used. Okay, so this is the effect of impurity on the nanoparticles. And third one, so these are biologically harmful. So that these are the metal nanoparticles are poisonous. Okay, so that these are all the biological. This is the toxic. Okay, and carcinogenic. And they cause irritation. So why? Due to this can easily pass through skin. So that in other way, skin is transparent to them. Why skin is transparent? Because skin contains some pores. Okay, the pore size is bigger than the size of nanoparticles. That is a problem. So that these nanoparticles are get into the skin, they cause the irritation, they cause the carcinogenic, they cause the usually they become allergic, like that. We should be careful. So that there's a explosive in nature. Next one, they are explosive in nature. Next, explosive. in nature. They having a explosive nature. Okay, so that here this is due to the exothermic combustion. This is due to the exothermic that lead to this lead to the explosion. Okay, so the metal powder, you know that I think you might have heard this, metal powders are used explosives. So for that was nanoparticles are so maybe explosive. And so last one is difficulty in synthesis. Last one is difficulty in synthesis. Yes, of course it is difficult. Difficult in synthesis. Why it is difficult? So the first thing is, so they are difficult to keep stable. Second one, stable. Second one, so continuous increase of size, so that the continuous, this is difficult to, so it's difficult to the required size, difficult to keep in the required size. This is another one, the problem. Okay, so for that purpose, for this we have to encapsulate. So these are all the drawbacks of the metallic nanoparticles. Thank you very much.